So, Ethernet, okay, it's a local area network technology. So when we're talking about Ethernet LANs, we're talking about the bottom two layers of the OSI protocol stack. Okay, so that's the Open Standards Interconnect. So host-to-host layer, if we're talking about TCP/IP stack. So there's a couple of different variants of the stacks. We'll cover those in a second. So it's the bottom bit. It's the physical layer and it's the link layer above it. So when we're talking about networks, okay, so local area network, generally we're talking about one building, a small area, okay? All devices connected to one common medium, okay? Could be fiber, could be coax, could be twisted pair. Metropolitan area networks, or MANs, so you'll see that as LAN, okay? Metropolitan will be referred to as a MAN, okay? Covers a city or a big area. I mean, the university has a metropolitan area network. All of our 5 campuses are hooked together with high-speed fiber. You know, multiple gigabit backbone. They rent fiber from local providers and put their own switches on the ends of them, and away they go. So, wide area network, or WAN, okay, can be thousands of kilometers, speeds up to gigabit per second. So these are the sorts of links you see between continents. You know, these are the fiber optic cables that run into the ocean. And again, companies like Rio, they have their own wide area networks. They actually either rent or get hosted for them links across the globe between all of the sites. So, you know, that's wide area network. You know, that's basically what the internet is. The internet is a multi-user wide area network. So OSI and TCP/IP. So the OSI stack starts with the application layer. So this is things like your web browser. Okay, presentation layer, it's sort of an aggregation between those. It sort of happens at the computer level. Session is connection. So this is a software connection between two computers or two systems. Then you get down into your transport layers, your network layers, data link, and your physical medium. So everything that works over the network goes down the stack, across over the network, and then back up the stack on the other side. So if you look at what's termed the TCP/IP model, it's broken down into much fewer slices here, okay? And you find that the network interface layer is equivalent to those two bottom layers. And again, your network layer is equivalent to your internet layer, and TCP/IP transports your host to host, and then they say, you know, session, presentation, application is all your process or your application layer on the top. So that's where the two models of how communications work sort of sit next to each other. And when you start looking at the standards in this space, okay, they don't perfectly fit into the OSI model. There's a little bit of overlap here. So the media access control layer just subtly, you know, bridges between the data link and the physical layer, and you know, the logical link control layer, which is defined by 802.2 LLC, that sits just up in that top of that data link layer. So again, you know, if you're looking at standards, you know, 802.3 is our internet, 802.4 is a token bus, which is another networking variant, and 802.5 is your token ring. So different variants in that data link and physical layer of handing the data around the system. So Ethernet is not the only one out there. There are others. Okay, there's ones that come back from the deep dim darks of IBM and are still used in banking systems. You know, there's still Novell's IPX underlying networking sitting out there in places. So Ethernet is the most common that's out there. So you know, there are others. So be aware, not everything is Ethernet. So what do the layer responsibilities do in the bottom end of the OSI where we're looking at Ethernet? So the layer 2 is concerned very much with the reliability over our connected link. Okay, so it involves framing up the data, the addressing of it, making sure the errors are dealt with, making sure we don't go too fast or too slow. It also deals with the access control to the medium itself. So that's what the data link layer is doing. It's all about the comms, the addressing, and access to it, and making sure that the data gets from A to B in a reliable manner. So that's what the data link layer is about. It's managing that link. Physical layer is actually getting the zeros and ones over the physical medium. Could be glass, could be copper. Okay, it's actually transmitting it. So when you're talking about TCP/IP, 1 and 2 are combined in what's termed the host to network layer. So Ethernet, where does it sit? Ethernet is layer 1 and layer 2. So it's covering the data link and the actual physical layer. So that's where Ethernet fits into those models. So does that make sense? That's the bit of the thing we're talking about. Excellent. So I'll try and remember to stop and ask and make sure that I haven't lost anyone. Sometimes I can get stuck on transmit. So, and I'm not as awake as I should be, because I do lighting and sound design for the local community theatre as well. So it's been a fairly big weekend of having a show on, and my son, who's 11 at the moment, has got a starring pivotal role in the current show called Closure. So he's a bit tired as well, and that sort of drags on the house a bit. So apologies if I'm not as awake and alert as I should be. So the standards for 802, okay, the local area metropolitan area network standards. So 802.1 is your internetworking. Okay, 2 is our logical link control. Okay, 3, collision sense media access collision domain standard. So communications, again touched on, these are all the standards for our physical, physical layers. And again, 11 for your wireless, so Wi-Fi that we use out there today. And again, 802.16, so this is sort of your WiMAX standard. This is your metropolitan point-to-point high-speed radio links. So again, the thing with networking, if you're looking for the networking standards, they're all probably likely to be under the 802 space. They'll be 802. something. So if you want to get into the details, then that's where you go hunting. Oh, excuse me. So yes, standard for that one, standard for that one, and then the physical layers in the other standards down here. So IEEE 802.3 CSMA CD is 10 meg standard, okay, commonly known as Ethernet, okay, originally developed by Xerox in the 1970s. Now, originally it was a bus-based network, okay, so it evolved over time. Now, when we get onto the wire, if we're lucky, we will see both of these standards out there. They are compatible with each other, and they work quite happily on the same wire. The original Ethernet one is obsolete. You won't see that out there now. The DICS consortium, DIC, Intel, Xerox, if my memory serves me correctly, was the first one that went out there in the Ethernet space. Now, that was commercially put out there. Like many things in the standard space, the 802.3 standard took a long time to get ratified and sorted out. Just like HTML5 standards taken a very long time to come to fruition. So the companies, the main ones in the networking space at that point, went, bollocks to this. We want to get some product out there. So just like you see now, with the new Wi-Fi modems coming out that are pre-approved, or they're compliant with the current version of the standard under development. Ethernet 2 was the original one that got out there and actually got driven by commercial entities and rolled out. And again, it morphed, and a lot of what was done in the Ethernet 2 standard ended up in the 802.3 standard, but they're not quite the same. So, as is often the case, when people want to ship product and make money, they get it out there. So what are the topologies we've got with LANs? Okay, all networks break down into a combination of these three things. They'll either be a bus, so a straight connection. There'll be a star, so a hub in the middle, spokes coming out, typical switch type approach, or there'll be a ring, where you've got a whole bunch of devices connected up in a ring. So rings can be good for redundancy, but they come with some entertainments on managing them. So we get into some of the industrial ring approaches down at about topic 4, I think. So you can get some hybrids. They look like a physical star, but logically they're connected together as a ring. Wi-Fi particularly, you'll get things like mesh developments. You can do mesh with copper as well, but you need lots and lots of network cards in each computer. So lots of things in this space come down to how critical is it that your network stays alive. So it all comes back to risk in this space for some of the topologies you use, risk, and how much money it costs you if you lose the network. So your bus topology, okay, pretty simple. You've got a terminator at each end, okay. You've got a medium that runs around your building, and you've got your computers, hanging off the network. Computer A wants to talk to computer B, passes the information over the network. Pretty simple. Everyone shares the same bus. Everyone's on the same link. So that was the original Ethernet on coax. So your star topology, hub in the middle, spokes out to computers A, B. The data flows through the middle and back out again. Okay, pretty simple. Now this is what drove the uptake of networking very, very quickly in the early days. Was the original 10 meg hubs out in offices. They'd drop a hub on the desk and run out very, very cheap twisted pair copper cable, connect everyone together very, very quickly and simply and cheaply. Ring topology, okay. So again, the data flows around the ring. It could be in either direction depending on how it's configured. Ring topologies need some careful management. Most rings you'll find tend to be broken at one point and then managed so that if there's a break somewhere else, then that break opens and the data is allowed to flow through. Depends on the underlying physical structure of the ring and how it's managed and what equipment you use. But rings are good in that they have built-in redundancy. So originally, shared medium. So we required medium access control. Okay, so it's evolved through time. So there's a hub star, which I'll look at in a little picky in a moment. It's physically still a bus network. So the original hubs were still actually working as buses. So I'll look at that in a moment. Then we evolved into the switched star, which is where we are today. It's why everyone calls them switches, because it shifted from being a hub to being a switch. So these switches, the benefit is you can get no contention between stations. Each computer has a computer-to-computer direct configured link. It's not sharing that with anyone else. Okay, the link is a one-to-one connect, and the switch manages it. So you're not trying to compete with your neighbor's YouTube traffic. If you're trying to talk to a different computer on the network, the switch keeps his YouTubing separate from your data and work. So it's one of the benefits of shifting from a hub to a switch. The switch has got some smarts to make sure that everyone gets the bandwidth they need. So bus topology, okay. So again, everyone's sharing this link, okay. If we've got computer C in here and it's transmitting as well, they've got to manage all of the flow. Okay, so you've got to manage what's on that wire, and that was one of the critical things with the early Ethernet, was coming up with how to manage this shared medium in the bus. So the other things with hubs is, in a hub, everything is just connected to the same backbone internally. Okay, so every device, even though they're plugged into separate ports, okay, so that's your RJ45 port. Okay, everyone is connected in the backplane, and all that data that flows in here from this one is sharing the same backplane in the back of the hub. Okay, so it's one of the reasons that hubs weren't so flash as networking devices. You could swamp them quite easily. So the move to switches. Okay, the switch is a full-on computer in the background. Okay, full duplex. So it means that there's a buffer on the port where you're plugged in. It's got its own management of the MAC, the media access control, and the physical control out to the computer here. If you've got a switch that's capable of 10 meg on each port here, okay, so each one of these is 10, then that switch, in order to deal with 10 meg, needs to be at least 40 meg capable in the back end. Okay, it's got to be fast, because it's got to be able to deliver 10 between here and here and here at the same time, and potentially here and here, and manage each pipe to be a full 10 megabit per second in the original standards. So it's one of the things with switches, and the reason that switches were much more expensive in the early days of Ethernet networking is that this core logic in the guts here, it cost money. It was extra chips. The old hub with the shared bus, very, very simple to do. But as electronic capabilities have come down, and the miniaturization of the chips needed, a switch and a hub, I don't know if you can buy a hub anymore. I've probably still got one in a box here somewhere. The better half gets grumpy occasionally at some of my boxes.